In this video, I'm going to show you how to use Microsoft Excel to calculate probabilities under the normal curve. I've written out the steps here for the process, and here is the question here. This is in the Excel file 07 probability confidence intervals, and we're in worksheet burglary. And as usual, the answers are in the red tab sheet down here, and you can see where we're going here. So the question is saying, assume that the average number of burglaries for towns in America is normally distributed with an average of 424 per year with a standard deviation of 86. What percentage of towns have between 300 and 400 burglaries per each year? So this is a straightforward probability problem, and the first thing we want to do is write down what we know. So I've written out the things we could possibly know here. So our population mean, is it giving us a population mean? Yes, it is, the average for towns in America, and that is going to be 424. The population standard deviation, it's saying, small towns in America, there's a standard deviation of 86 burglaries. We know that it's normally distributed, it's told us that. And it's giving us a range between two x values. We want to know the probability of being between there, which is going to give us the percentage of towns that have between 300 to 400 burglaries each year. So we have 300 is our starting value, and 400 is our ending value. And over here I've made a little, well, it's actually quite big. I've made a quite big picture here that you can see. You can do this however you like. You can do it on paper. You don't have to do anything fancy like this, but the picture is optional. But I would recommend you draw a picture before proceeding, and make sure you clearly label things as you go along. And the first step here would be to label your population mean right in the middle, and what you want to obtain. So you want to know this area here between 300 and 400, just so you know they're both on the left side of the population mean. That'll help you to visualize what it is you're trying to seek. So the next step is to translate the raw scores into z-scores. So there's our formula right here, which is telling you how to do that, and we can just plug in our starting z equals, and we can just plug in the formula. So what we're going to do, we're going to subtract the starting x value, x, minus our population mean, 424. And we're going to divide that by the population standard deviation. So this number here is giving us the number of standard deviation units away from the mean for the point 300. Our next one is the same as before, so we're just using instead the ending x point to give us our ending z-score, subtracting our population mean and dividing by the population standard deviation. The next step is to look up these probabilities in the table of the normal curve, or you can also use the normal standard distribution formula. So I'll show you how to do both of those. So first of all, let's look up the values in our table, our z-table. So we want to look up the z-score of negative 1.44. So we're on the left side here, so we know we're in the negative z's. So let's look for z equals negative 1.44. Negative 1.4, 0, 1, 2, 3, 4. So our probability of being to the left of 1.44 standard deviations is going to be 0.0749. So I'll copy that, Control C, and I'll go back here and I will paste that in here, Control V. And the same thing for our ending z, which was negative 0.279, so rounding that to negative 0.28. So negative 2, and 8 is the column here. negative 2.8 would get this probability right here. The other way to do this, you can do it whichever way you find is easiest, but I think this is pretty cool. So this is how I actually generated the table, the actual z table that I handed out to you. So the way to do this is just to type in norm, and we're looking for this normal standard distribution here. It's telling you it's going to return the standard normal distribution with a mean of 0 and a standard deviation of 1. So it's asking us for our z-score. So for our starting z, you can click on our starting z. We want to put in true because we want to calculate the cumulative probability. In other words, the probability all the way from the left end of the curve up to this particular point. And it's going to be, we can just copy this formula down because it's going to be a relative reference. It's just already done it for us. Okay, so B19 and true. And you can see that these have given us very similar answers. These are rounded somewhat because I only looked up onto the hundredths point in that chart in the z table. Okay, but they're basically the same exact numbers with a little bit of rounding. So basically the 1.44 and then the rest was chopped off. And the same thing here, the 0.28 was rounded up. And this one is rounded down. So our next step, step 3, is to subtract the probabilities that we've calculated. So what we're doing here, we've calculated our starting z right here, the negative 1.442, and we have the area to the left of that. Okay, this area here. And we have our ending z, the negative 0.279, and we have the area to the left of that. And the way to get this sliver here in the middle is to take the big one and to subtract the little one. So equals the ending probability minus the starting probability is going to give us the difference. And the last step is to interpret what we have. So what was our question? What percentage of towns have between 300 and 400 burglaries each year? So our answer here is 31.54%. 31.54% of towns in America have between 300 and 400 burglaries per year. And that's it.